I think I'm now recording the full screen. All right, so we're up to Chapter 2, and this is explaining why this class exists. A person might reasonably think that a general security class covers enough about DNS security, but that is not true. There are a lot of special considerations for DNS, which is why we're here. DNS exists because the internet grew too fast, which is the source of almost all the problems on the internet. Originally, the internet was only 4 computers, and the computers were so expensive they thought it would never get much bigger, so they designed the original system with just one number to specify what network you're on, and that would be limited to about 200 total networks, which is all they thought there would ever be. As the internet grew, there was just a small file called hosts.txt that listed all the current hosts, and you would just fit it on a floppy and mail the copies of the floppy to people or things like that. So this is what's on there. And this is all, like the telephone network, the internet carries legacy inside it. And the hosts file is still used on your computer. Most of the time there's nothing in there, but you can put things in there, and these days the most popular reason to put things in there is because you are a malware author and you are trying to steal money from people by tricking their computer into going to the wrong website. But it remains, and so people will get this thing, which is then stored in its hosts. So DNS started in 1983 because the number of machines on the internet was too large for that system to work anymore. And the idea here was you would have a distributed storage with copies of the database in many servers all over the place that would have a protocol to duplicate the data. And therefore, even if machines go down and network links go down, most people would continue to be able to reach the domain name system, because without that, the whole internet becomes almost useless, because you can only reach resources if you've memorized the IP addresses to get there, and you can't use alphabetical names like yahoo.com. So they served this hierarchical name structure where you've got a top-level domain, and originally there were only 7, like edu, com, and mil, and org, and then you'd have a name of your company here, and then you'd have a host name here, and perhaps even another one before it. This whole thing is called a fully qualified domain name, which specifies one unique computer. The company, the type of company, and the specific device at the company are here, so this will map usually to one IP address and one specific machine. That was the idea. So this means you have a hierarchical namespace. There is a root of the whole system called dot, which is a system, 13 server clusters, and those clusters do not have information about any specific domain like yahoo.com. They have the top level domains, or .com, .net, .us, .mil, and so they have the .com servers, all they know about. But if you ask them, I'm looking for ccsf or yahoo.com, they'll say, well, I don't know where that is, but I know where .com is, so go ask them. And then you ask them, where is yahoo.com? And they'll send you down here to yahoo.com's authoritative server, where you get an answer about any host you want to reach at yahoo.com. So it can take 3 successive queries to find what you want. And this is, that's the hierarchical system. And they call this DNS Zones. When you configure a DNS server that is authoritative, it is authoritative only over some zone. Like there's a server here at City College, ns3.ccsf.edu, that is authoritative over the ccsf.edu domain. That's our zone. So it's the way it's done, actually done here. We have one server that covers everything here, right? That server has all the records for all the servers on campus. And if you ask that one server, if you're looking for fred.ccsf.edu, ask that one server, it says there is no Fred. You don't need to hunt anymore because that's the authoritative server. And if it says there's no Fred, there's no Fred. And that's the game here. So you can choose to split your company apart. Another way we could have done it, and the way they had to do it at another community college around here, Evergreen, is there was a political issue where the independent branches of the college did not want to be seen as less important than the main one. So instead of them all being in one domain like ours, they split them into 7 Active Directory trees and had to do cross-forest trusts between them all, as if they were like independent companies that didn't trust each other for political reasons. But anyway, then you could have the Ocean campus could have our own name server, our own web server, and Mission campus could have their own servers, the other campus could have their own server, and then each could have their authoritative server, authoritative only over ocean.ccsf.edu. And then the domain names will be longer, www.ocean.ccsf.edu, but that's another way to go. And you often end up with this when companies buy other companies. They integrate their existing network structure in without modifying it much and leave it as an essentially separate tree, just connected to the first one. All right. So your DNS client is the software in your computer or whatever device you're using that does this DNS resolution. So it's typically something like a browser, but it could be an app on your phone or pretty much anything these days. It somehow has a domain name that describes what you're trying to reach, like you have some Apple Watch and it wants to get an update, so it wants to reach apple.com. So it knows the domain name. It will then send a DNS query to your server, whatever server it can reach, and ask where is apple.com. Now typically, you get the server from your ISP, provided from them. But anyway, the server is the device that stores and serves data. And a DNS resolver is software that will find a server and just get the answer. All right. So DNS servers, there are two major types. There's authoritative servers and non-authoritative servers, and they serve completely different purposes. And one of the big security mistakes you can make is to get these confused and run them both on the same server. An authoritative server is the start of authority for your little domain. So it should not be used to resolve general web surfing for people. So you have end user hosts here. They're trying to go to the internet, yahoo.com, google.com, and all that. You have a DNS server here, which is a resolver. And this will do recursive queries, which means if you ask it, where's yahoo.com, it won't say, I don't know, go ask somebody else. It will go ask somebody else, find the answer, and tell you the answer. But it doesn't actually know anything. It's just getting data from elsewhere. The authoritative server is the one you use for people from the outside trying to come into your company, telling them how to find the resources at your company. And that's a completely different job, and it is not wise to try to mix these two with the same server. You have one that permits recursive queries for your employees to use to surf the internet, and you have one that does not permit recursive queries to be the authoritative one. It's not used to find other places, it's just used to find out what's on my domain. All right. By the way, most servers are caching, which means they remember recent resolutions, so they don't, if 10 people go to Google, they don't bother asking Google 10 times where it is, they just ask once and then repeat the information to others, storing it for a certain amount of time, and you'll see a TTL. When you define your domain name and you give it a record, you specify the time to live, and that's how many seconds people should hold this information before asking again. So if you don't move around a lot from web host to web host and you want to save resources, you put in a large TTL, and then your server will not have to handle as many requests. But it also means if you do change, it could take up to a TTL of time before people find you. They'll keep going to your old host.
So I thought time to live was for like hops or something like that.
What's that?
Is time to live an actual time or is it in hops?
Well, that's a different issue. There's time to live in TCP, in layer 4, but that's not what this is. This is a layer 7 DNS time to live. Happens to use the same phrase.
Okay.
Yeah, it's not that time to live, you're right, that's hops to go around the world, and that's just to make sure that packets don't go around in a loop forever. But this is a different issue. This is how long you hold cached information before you read it.
Okay, thanks.
And by the way, you can see it. If you use dig, let me bring it up here. All right, let's blow this up. All right, if I do, blow it up a little more. All right, if I do dig for an A record of ccsf.edu, I get the IP version 4 address of our server, and I have a number there. And if I do it again, that number went down. It was 592,000 seconds, 854. Now it's 287. It's going down. That's the cache time going down. Well, that looks kind of random to me. Let me try a simpler one. yahoo.com. There's one, and if I just watch it, it'll refresh every 2 seconds, and that's a sort of simple way to see what's going on here. All right, there, so it's going down. Now what's happening here, the reason it's jumping all over the place is because they have a cluster of servers. You're not always asking the same server. So I'd have to have a much simpler system. And let me go through a couple steps here. It's a bit of what we did last time, but it's all right. Let's do the start of authority for ccsf.edu. So the ccsf.edu starts from ns3.ccsf.edu. Now I think that is actually a single server and not a cluster, because we're not a very big organization here. So if I do a, let me bring this up a little higher. All right, so if I do a dig at ns3.ccsf.edu for, say, hills.ccsf.edu, I get nothing. That's rude. Well, do I have the internet at all? I do have the internet. All right. Let's just try ccsf.edu there. Right. Well, let me go back to my slides. We'll come back to this stuff later. I've got some other those will work better.
Like network security stuff, like I can't use like any VPN software. I can't go ahead and log into TeamViewer. And there's a lot of.
Yeah, the wireless network is very restricted here, but you certainly the wired network is less restricted.
Because I tried it on the like on a hard line as well, same thing. I mean, like I can't actually get anywhere. I mean,
You have to register and log in to use the City College wireless.
Yeah, I did that already.
Oh, well, then you should be able to reach those services, but there's often problems with it. Anyway, like I said, recursive queries are where you ask the resolver, and the resolver, if it doesn't know, it will do the queries on your behalf to find out and then tell you. An iterative query is where the server will not do anything but tell you what's in its own zone files. And if it's not in its zone files, it will say, no, I don't know, go ask somebody else. And then you have to figure out who else to go ask. So a DNS forwarder is something you can use to cache more records. So if you have an expensive link here and you don't want people going off to the internet looking for resolvers, you could use a forwarder, which will send external queries away. So recursive queries are here, and if you have queries that go outside your network, they go through the special forwarder, which caches more information to try to decrease those expensive calls outside your network. All right, and so a DNS resolver gets the request from a client, it then queries the servers, and it can then respond. Windows has a resolver built into it. If you resolve a domain name in Windows, and then you go to that domain name again a minute later, it does not do another DNS request, it remembers. Linux, like Ubuntu Linux, for example, does not. If you go to Yahoo, and you go to Yahoo again, it makes a second DNS request to find it. I don't know why they did it that way, but anyway, that's the game here. Windows caches and Linux does not cache. So you can make a local DNS server. This is what most people are using, and they don't know it. When you join you pay Yahoo or pay Comcast or Verizon or somebody to get an internet connection, they give you an IP address and they give you a DNS server to use. And it all comes down through DHCP, so you're using their server. So everybody using Comcast in a town or a part of town is all sharing the same server. In the past, this was very commonly extremely slow, flaky server that was often down. It was often the problem for internet being slow. So a lot of us, like me, got in the habit of using other servers. There are people that run public servers like Google and OpenDNS, and you get these numbers memorized, like 8888 is Google's public one, and you can use that anywhere. In most cases, using the one from your internet service provider is actually a little faster because it's closer to you. You have direct connection to it, but I have enough reliability problems that you often want to have another one to use for when it's not working. So here's the typical name resolution. You ask your local DNS server, where is ccsf.edu, and it is a recursive query, and this the recursive resolver. So it doesn't know the answer, but it won't tell you that. It will go find the answer. We'll go through this process. Ask the root, where is edu, if it doesn't know that. Ask edu, where ccsf.edu is, if it doesn't know that, and then ask the server down here, where is ccsf.edu. It'll do those 3 steps. Now, in practice, it almost never does the first one because it caches that for a whole day. So only the first query every day has to ask the root where things are. But occasionally it does have to ask the root where is edu.
On both Windows and Linux?
Yeah. Because it doesn't even know or care what your OS is here. This is all the servers, and they are running on both Windows and Linux and Unix. All right, so that's the process. And I've got a few iClicker questions. Come grab one if you don't have one. Leave your name behind, but don't put anything valuable in that box. Everybody should have one of the white iClickers. And let me see if my software is going to work. I've got updated software, which is slower but sort of prettier. All right, looks like it's going to work. All right. So let me just start this thing. And go ahead, just press like A and E. I just want to see, yeah, there you go. You should see some numbers here. Make sure people got your iClickers working. There must be at least 20 people out there. And you can vote until I stop the time, and your last vote is the one that counts. So if you don't have anything expendable, just write your name on a scrap of paper. Not a credit card or something, is it?
Yeah, it's just my
Good, okay, that's good. Yeah. That's the important thing. All right. So far, no one's had their identity stolen in class. I'd like to keep it that way. That would be sort of embarrassing. All right. So, we start it again and show you some questions. All right. So what is www in that URL? All right. Looks like I can quit at 35. All right, that is a host name. Not a very popular answer. That's a host name. That is the particular host at the domain yahoo.com, the www is. It's not necessary, by the way. An awful lot of people have a habit of putting it before every URL. But many places, like my website, is not named www.samslash.info. I put in a DNS record to resolve that because so many people will type it in. And a lot of browsers will automatically put this in and omit it now, trying to compensate for people guessing about domain names. All right. I said, okay. All right, how about com? What is com? All right, com is the top level domain. Good, the most popular answer is correct. All right, there were originally only 7 top level domains: com, int, mil, edu, and a few others. Now there's many of them. Anybody that wants to make a top level domain can make it, but it does cost $200,000. And that slowed people down, but there is .horse. You can make a domain .horse now if you want to. Anyway, I guess there must be a rich horse lover somewhere. Anyway, all right. So what file connected names to IP addresses before DNS? Quit at 30. All right, that's the host's file, and good, there we go, popular answer. All right. All right, if we add a new server named Wall, where should the administrators put that information? Put it at 35. Looks like there's still a few answers coming in. All right. It should go on a DNS server, but in particular, it should go on the authoritative DNS server. That's the one that all the other name servers that are not authoritative have copies of the data from the start of authority. You put the new thing there, and in the natural course of replication, a zone transfer happens, and it updates the others. So this is the best answer. That's where you put new information, and there's even version numbers in that. One of my students that worked at Cloudflare figured this out about a year ago. The semester started, and the website was up, and then it was down, and then it was up, and the same thing for the online courses. Every day it would be up and down at random. This went on for about 2 weeks. And so I thought it was just my internet connection or something, and then and one of my students found out that somehow 2 servers had gotten wrong version numbers of the updates. So our secondary resolvers were getting an update which was wrong, and then another update with a later number, an update that was right, and then an update with a later number that was wrong, and then another update. They were just canceling out. We figured that out. Until then, I did not know that there is a version number on every update for a zone transfer, and that's how it knows whether to update its records or not. Anyway, the start of authority is where it all starts from. All right. What's the most common type of query? All right, and that's a recursive query. For the most part, that is what you normally use when you're surfing the internet. The clients use recursive queries. Because I just want to find it, I don't really care who you have to ask to get it, just find it and tell me. All right, so we're not up to an hour yet, so let's keep going here. All right, so as I mentioned, there's DNS replication. Let me drag this thing out of the way. Come on, come on. There it goes. All right. And now this thing. All right, that's not bad. All right, so there's a master server that has the primary data for your zones, and the slave servers have copies of it. And this process that moves the data across is called the zone transfer. And that happens on TCP port 53. Resolutions used to happen almost exclusively on UDP 53. Now they can use either. Anyway, the root servers are named dot. The only thing in the dot server is the top level domains. .mil, .gov, .biz, and all that jazz. So if you just rebooted your DNS server and it doesn't know anything, then the first query it gets, it has to ask dot. Like here's something called .com, where would that be? Ask dot, dot will tell you where .com is. After that, it caches the information for a whole day and it will not really have to ask again, except once for each top level domain. All right, the root server is in fact hundreds of servers in 13 clusters dispersed around the world, and they have names like this, A, B, C, and on rootservers.net. They've been up for a really long time. They are the heart of the DNS system, and as we talked about last time, they're very, very hard to bring down. There have been several attempts to bring them down with attacks. None of them have ever succeeded in bringing these down. So we should talk about the way the data looks in DNS. There are different kinds of records, and here's the common records. The most common by far is A. This is an IP version 4 address, so you can find a server. This is almost all the time what people want. However, nowadays, in America, more than 10% of the traffic has converted to the new system, IP version 6, and they use quad A for those records to get these long hexadecimal addresses, which are replacing the old IP version 4 addresses. So that's just to reach a server to fetch something like a web page. Then if you want to send email, you need a mail exchange server. If you want to receive email and you don't want to get spam, you typically request a pointer record, which is used to designate which servers are supposed to be sending emails for that domain so they can notice some kinds of spam, or it's lying about what domain it came from. And there are other uses of pointer records like reverse DNS lookups. Here's where you find the DNS servers for name servers, and there's other things like canonical name, which can be used to store text records that can store basically any kind of data you want, used for special purposes and not that common. A canonical name is used if you want to have two names for your domain. For a long time, City College's official domain name was ccsf.cc.ca.us, meaning Community College, California, US. And ccsf.org was a canonical name that pointed to the others, which means we could use it, but in fact, anybody that would try to go to a website and type in ccsf.org would have to do two queries. First, they'd have to ask what ccsf.org is, and they would get told it's ccsf.ca.us, and then they'd have to query for that to get an IP address. So it doesn't really matter for most terms, but it is a little bit slower to use canonical names that force people to do multiple resolutions to find things. And the start of authority, we talked about before, this tells you the server that defines the zone. Then you've got a few other ones less rarely used, naming authority pointer, service for specific application, and sender policy framework, which I mentioned. Spam has been an enormous problem on the internet for a long time. More than 90% of all the email is junk. Nobody wants it. The receivers don't want it, and the internet service providers don't want to waste bandwidth delivering it, and the email servers don't want to waste bandwidth delivering either. So at every stage, everybody is vigorously trying to filter out the spam, as you can see, without great success. Tons of it gets through anyway. And so there are many additions tacked on to the internet to try to stop spam, and one of them is sender policy framework. All right. And then we get down to DNS Sec. DNS Sec is the encryption and signature protocol for DNS, which is still in its infancy, gradually rolling out, and it is not yet to the point where it's actually doing you any good at all. And it probably will not reach that point for 5 to 10 years. But it has a whole bunch of these records, DNS key, DS, RSig, and NSEC, which are cryptographic numbers, which are signatures, that in principle mean that when this is finished rolling out, you'll be able to be sure that you're actually getting accurate data from the right server, instead of lies from a false server. So let's try a few of these. So if you want to see City College, let's see if this is going to work better now. dig a, ccsf.edu. All right, so that tells me the identity, and I got that from my configured server, which is in fact OpenDNS, 208.67.220.220. That's one of the names I memorized. If I'd rather get it from Google, I should be able to do this. There we are. So now I got that from Google's server. At 8.8.8.8.43, now Google's server in this case has the same information. That's not necessarily always true. All right, so now that told me just the A record, which is the IP version 4 of our main web server. But if I want all the information about the domain, that at least a large collect of it, it doesn't give you everything like a zone transfer would, but it gives you a large group of records. You dig any of ccsf.edu, and this tells you the A record and the start of authority and the name servers. In this case, it didn't tell me the quad A record. Perhaps we don't have one. That's right. I think City College has not upgraded to IP version 6 yet. We don't have a quad A record. So you see here up here, notice this stuff, query 1, answer 0, authority 1, additional 0. So this is an authoritative answer. You can trust it. But the answer is no. We do not have an IPv6 record, which is pretty out of date and sleazy of us, but we've had other things a higher priority around here. I've got one, because I don't have to carry around the legacy that City College does. And there it is, because I use Cloudflare and they get it here for free. So I have 2 IP version 6 records, and if I dig any on my domain, please stop asking for any. Neat. Cool. I wondered about this. See, this is kind of a side story that's interesting. See, Cloudflare's primary purpose is to stop denial of service attacks. Well, to be fair, their primary purpose is to make websites load faster. But their second purpose is to stop denial of service attacks. And they are pushing against protocols you can use for amplification. And any is one of them. And I haven't seen this before, but I've been expecting it. People are beginning to write standards saying you should quit using any, because you should just ask for what you want. Any just makes a big response, which is used by attackers to get. That's kind of cute. And Cloudflare would be the first one to jump on that, of course. Anyway, we'll see a few more crazy things going by here. So let's try the IETF. You'll see somebody that really is using all the latest standards. If we dig any, ietf.org, let's see if it works at all here. Okay, now this is interesting. On campus, I got this answer. Now I happen to know that's not a very good answer. Did I spell it wrong though? No, I spelled it right. Okay, let's use a looking glass service. See, our campus DNS infrastructure is not that upgraded either. So to see a better answer, let's do what you're going to do in Project 3 and use an off-campus looking glass, which gives you a more direct answer. And the one I want, come on, it's up here. All right, there. Ring of Saturn is one of them. If you just Google for looking glasses, there are quite a few people that let you run servers so you can see what's really happening on the internet, even though your local network isn't letting you directly connect to it. So this is web-based dig. So I can dig anything. So now if I dig any ccsf.edu on this one, they will do that dig and then let me see the answer and deliver it to me over HTTP, so my local network is not that important. And there's the answer, and you see it's pretty much the same. It does give me more of a complete answer. It automatically did a trace. So it showed me the whole process of finding ccsf.edu here, and then going to the edu servers and the name servers here, and the A records here, and the quad A record there. Those are all facts about City College. But what I want to do is compare that to IETF.org, the Internet Engineering Task Force, which defines all these standards and is therefore, of course, employing all the recommended latest stuff. And there you go. This tells me I get this RR-SIG record, which is what I was talking about before. Now, this is not penetrating into the City College network because these records are too big to fit with the old-fashioned DNS, which you may remember is only 500 bytes long. So you have to move them by TCP or by extended DNS, and our local network is not updated to that yet. So that's why I use this looking glass. But the point is, this is what you get now. Up here I got, you get these long answers with these long cryptographic signatures identifying the server. Anyway, and if everybody had upgraded to using those things, then browsers might actually verify them, and then you could trust the answers better. But we're years away from that. So that's the DNS looking glass. All right, I got a few more iClickers. This is like a pretty good place to put that thing. All right, 13 of these servers. 30. All right, and those are the root. Whoops, that's not right. All right, I got to go back one now. There we go, the root. Good, 13 root servers. There are actually 13 clusters, but they appear to be 13 servers. All right, what record has data that looks like that? And the spelling checker really gave me trouble about this. There, okay. All right, I'll quit at 25. I think the answers are in. All right, that's a resource record signature. Item B here. There are a few cryptographic things, but that's the one that is on cryptographic quantity. It's in base 64 and just random numbers for all practical purposes. All right, what record looks like that? All right, I guess I'll quit at 25 again. All right, that is an A record, the simplest one, just a plain old address record, the most popular answer. That's what most people mean by the address, is the good old-fashioned IP version 4 address, which is what most people are using. All right, what record stops spam? At 25. All right, and that is Sender Policy Framework. By the way, as you know, it doesn't work very well, and that is because one truism I've heard from people who analyze the criminal underground is that if you take over a computer, the most valuable thing you can do with that computer is send spam. I don't believe that is probably true anymore. I believe the most valuable thing you can do now is CryptoLock. That is the new way to just make money off the internet, and it's growing like mad, and there's no end in sight. But anyway, before that, people said the most valuable thing to do was to send spam, because 1 in 1,000 people will actually buy junk from spam, click on that link, and that's just money rolling in, as long as you're not paying for the bandwidth or receiving all the complaints because you use somebody else's equipment.
I thought PTR records were mostly, that's the one I use mostly professionally.
Well, the PTR records actually include the SPF data, and you're right. Maybe I should. I don't think I'll change it. Now, maybe I should change that. Yeah, that's very smart. You're being too smart for me. Be good. By the way, in case anybody doesn't know, these are just extra credit, these questions, because I'm aware of the fact that they're kind of imperfect. So there are various defects in this as a way to grade people. This is not how you take the final exam. All right. Anyway, what DNS record looks like that? You got a pretty good point about PTR. That's a problem. All right. Anyway, I'll quit at 25. That's where the SPF really usually is. Yeah. All right. Anyway, this one is a quad A. I think there's only one good answer this time. All right. Good. All right. So we got some more to go. Let's take a break for 10 minutes and come back at 7. I'll stop the recording, make it in 2 pieces. This is 40, chapter 2A. All right.